Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we will create an assembly file of shock absorber in SolidWorks, which is taken from our suspension assembly. In this video, you will learn the full modeling process of this model and its components. Okay, alright, we have used 13 part files and 4 subassemblies to make this assembly. Some pics we are showing you at the beginning of this video. Okay, that's it. So let's start the tutorial. Now we will create a new inch part file from here in SolidWorks. Click OK. Now we will activate the extruded boss base command from here. Select the front plane to start the new sketch. Now we will draw a circle from the part origin and its diameter will keep 0.525 inches. Okay, finish the sketch. Now here we will set the extrude depth value 0.075 inches. Click OK. Now see, my first boss base extrude feature has been created in the design window. Now we will change the color of the model like this. Okay, now my model is looking perfect. Save the part file with the name shock spring adjustment nut. Okay, that's it. Let's start the new sketch over the front face of the model. Now choose the front view. Draw a polygon from the center part origin. Select this vertical line, choose to make vertical. Now we will activate the Smart Dimension tool from here. And fix the dimension 0.625 inches between these two vertical lines. Okay, finish the sketch. Now activate the extruded boss base command and select the polygon. Okay, enter the depth value 0.125 inches and click OK. Now rotate the model in the back side. Activate the Extruded Cut command. Draw a circle over this face and its diameter 0.5 inches. Okay, finish the sketch. And cut the circle through all over the body. Okay, now see the result. We will activate the fillet command from here and enter the radius 0.05 inches and apply the fillets over all the polygonal edges of the part. Okay. Okay, that's it. Now we will give some more fillets over the part like this. Okay, alright, now my part is completed on here. Next, we create a model spring on here. Now we will create a new part file. Click OK. Now we will go to the Edit Document Units tab. Activate the IPS option and set the decimal value up to 4 places on here. Click OK. Now we will change the scene of my background. Now select the backdrop studio room option. Okay, it looks great. Now we will select the front plane to start the new sketch. Create a vertical line on here. And fix the coincident relation between the midpoint of this line and part origin. Its length will keep 1 inch. Now we will create 2 circles on here. Its diameter will keep 0.043 inches. Now we will apply the equal relation on these 2 circles. Select the center points of the circles. Make vertical. Create a point on this circle. Okay, create one more point on here. Apply the tangent relation on these 2 circles. Now we will select this point and the end point of the line. Fix the horizontal relation between them. Okay, that's it. Convert the center line into construction geometry. Now select this point and the center construction line and fix the diameter dimension. It will keep 0.55 inches. Now we will choose zoom to fit option. Okay, alright. my sketch is fully defined in the design window. So we will exit from the sketching environment. Now choose an isometric view. We will activate the plane command from here. At first, we will select the center point of the top circle. Okay. Then next, we will select the top plane and click OK. Now see here, plane has been created over the center point of the circle, which is made parallel from the top plane. We will create a new sketch on this plane for making helix cross section. Okay, create a circle from the part origin and snap it on the center point of the top circle. Okay, alright, finish the sketch. Hide the visibility of this work plane. Okay. We will go back to my base sketch and convert the lower circle into construction geometry. Because the Helix Spiral tool will not select the sketch properly. Okay, that's it. Finish the sketch. Now we will activate the Helix Spiral tool from here. First of all, we will select this circle for helix cross section. Okay, now see the helical curve preview is visible here in the design window. Set the height and revolution option under the define by area. Fix the height value 1 inch and set the revolution value 5. Then fix the start angle value to 70 degrees. Now see the helix direction is visible on here. And click OK. Save the PAR file with the name suspension spring. Click save. Okay, that's it. Now we will activate the swept boss base command. Okay, first of all, we will select the small circle from here, which will keep as a profile. And then next, select the helix curve from here, which will keep as a path. Okay, that's it. Now you can see in the design window, my swept boss base feature preview is visible here, and click OK to finish the command. Now see the result. My suspension spring has been created successfully on here. Okay, alright, it looks great. Now we will activate the document properties button on here. Go to the image quality section and here we will increase the shaded and draft quality of the spring model so that the edges of my model look very good. And click OK. Now see the result. Now we will change the material of the model as chromium plate. Okay, my model is looking perfect. Let's start the sketch over this plane. Open the visibility of sketch 1. In the same manner, we will create one more helix cross section on here that we had done previously. Okay, alright. Activate the Helix Spiral tool from here and select the circle. Now activate the reverse direction button on here. Okay. Select the pitch and revolution option. Fix the pitch value 0.043 plus 0.001 inch and set the revolution value to. Choose the counterclockwise option and click OK. Now see. In the same manner, we will create another sweep boss base feature like this. Okay, it is looking very fine. Start the sketch over the front plane. Take the project of the entire model by activating the intersection curve command. Enable the section view on here. Now we will rotate the model in this position. Convert all the sketches into construction geometry. Now we draw a rectangle on here. And fix the tangent relation between this rectangle line and this curve. Okay, alright. Finish the sketch. Choose an isometric view. Select the line of the rectangle and start the Extruded Cut command. Now we will choose the through all both option and click OK. Now see, my bottom surface of the spring model is plain on here, so that we will place the spring easily on my suspension assembly. Okay, that's it. Open the visibility of sketch 4. Create a new plane over the top end of the spring like this, which will be made parallel to the top plane. Start the sketch over this plane. Now we will create another circle over this plane for creating a helix cross section. Okay, alright, finish the sketch. Activate the helix tool and select this circle. Same values will keep on here. Deactivate the reverse direction option and choose the clockwise option and click OK. Create a new sketch over the top face of the spring and take the project on this edge. Okay, that's it. Finish the sketch. Now we will create another swept boss base feature like this. And now we will open the visibility of sketch 4. Okay, and activate the plane command. Now select this point. Okay, and select this point and select the third point. Okay, alright. Okay, now see the result. My 3-point work plane has been created on here. Let's start the sketch over this plane. In the same manner, we will plane the top face of the spring by using the Extruded Cut command that we had done over the bottom face. Now my suspension spring part has been completed on here, so we will close the par file. Now we will create another new inch par file on here. Click OK. Choose different plane, sketch. Create a circle from the center part origin, and its diameter will keep 0.5 inches. Okay, finish the sketch. Activate the Extrude boss base command from here. Fix the depth value 1 inches and click OK. Now we will save the part with the name shock body 1.3 length. Okay. Okay, now we will activate the shell tool from here and select the front face. Set the thickness value 0.035 inches and click OK. Now we will apply the fillet on this edge. The fillet radius will keep 0.05 inches. Let's activate the Extruded boss base command and start the sketch over the front face. Now create a circle on this face and fix the diameter 0.375 inches. Okay, finish the sketch. Enter the depth value 0.4 inches and click OK. Now we will create another new sketch on the front face. Draw a vertical construction line on the center part origin and take the project of this inner edge by activating the Convert Entities command. Now we draw two vertical lines on both sides of the center line. And select these three lines on here. Choose Make Symmetric. Okay. Apply the dimension 0.15 inches between these two vertical lines. Fix the coincident relation between this endpoint of the line and the inner circle. In the same manner, we will fix another coincident relation over the opposite line. And now convert this circle into construction geometry. Otherwise, the extrude cut feature does not pick up the sketch at a time. Okay. Now create a center point arc on the both sides like this. Okay, now exit. I will choose the cut extrude and okay, select the sketch. Okay, see. Now I will create one more cut extrude feature on the opposite side. I will select the extrude cut command and select the side face. Okay, now draw a circle. Its diameter 0.24 inches. And distance from the outer edge 0.1875 inches. Now select these 2 points and choose make horizontal relation. See, my sketch is fully defined, so we will exit the sketch. Now select the circle and condition keep through all both. Okay. Now I will apply some chamfer and fillet over the hole. Now I will start the cosmetic thread tool from here. First I will choose this circular edge. Okay. Now I will select the 1/2-20 size here. Thread depth keep 0.75 inches. Now I will select the front face of this model so that my cosmetic thread has started from here. Okay, now see. Okay, now we will apply another cosmetic thread over the hole like this. Okay, this time thread depth keep 0.375 inches. Okay, now I will change the color of the model blue. Okay, it is looking perfect. Now save the file and close it. Now we will create another new inch bar file from here. Okay. First of all, we will activate the extruded boss base command. Choose front plane to start the new sketch. Now we draw a circle from this origin point. Its diameter will keep 0.5 inches. Okay, finish the sketch. Enter the depth value 0.125 inches. Click OK. Now see, now choose isometric view. Okay, and change the color of this part like this. Save the file with the name shock cartridge. Okay, that's it. Select this face, sketch. Now choose front view from here. Okay, and create a polygon from the center point and snap the polygon point over the outer edge of this feature. Okay, now choose make coincident over this point. Finish the sketch. Activate the Extruded Cut command and select the polygon from here. Okay, now select the flip side to cut option and enter the depth value 0.11 inches. Now I will activate the fillet command, constant size fillet, symmetric, and 0.005 inches the radius. Now one by one I will choose all, but I will choose the right feature option on here, so it will automatically select all the edges of the part. There is no need to select one by one. Okay. Okay, alright. Now my part is looking perfect. Now rotate the model in rear side. And activate the Extruded Boss Base command. Select this face to start the new sketch. Now we will create a circle from here and its diameter will keep 0.43 inches. Finish the sketch. Enter the depth value 0.25 inches. Okay, alright. Now we will start the new sketch over this face. Create a circle from here. Its diameter will keep 0.25 inches. Finish the sketch. Now activate the Extruded Cut command and select the circle. Okay, enter the depth value 0.29 inches. Okay, alright. Now my hole is created over this face. Now we will activate the Extruded Cut command. Okay, select this front face. Draw a circle on here. Its diameter will keep 0.135 inches. Okay, that's it. End condition keep through all. Okay. Okay, now I will choose the top view. Select top plane, sketch, activate the section view by selecting this plane. Okay, that's it. Now we will take the project of the entire model by activating the intersection curve command and convert all the sketches into construction geometry. Now we will draw a vertical construction line over the part origin. Now we will draw some more lines over this edge. Okay. Select this line and this line, fix the dimension 0.025 inches. Okay. .05 inches. .025 inches. Okay, that's it. Select this line and center construction line, its dimension 0.375 inches. Okay, that's it. Finish the sketch. Now go to the isometric view and deactivate the section view. Now we will activate the Revolve cut command from here. Okay, choose the center line. Okay, that's it. Now my feature is cut on here. Now we will apply the fillets on these two circular edges. Okay, it looks great. Activate the cosmetic thread command and select the ANSI option under the standard section. Okay, now select the back circular edge to apply the thread. Okay, alright, my part has been completed on here, so we will close the part file. Now create another new part file on here. Let's start the sketch over the front plane. Now we will draw a vertical construction line on the center part origin. Draw a circle on here. Its diameter will keep 0.0625 inches. The center distance of the circle will keep 0.094 inches. Fix the horizontal relation between the center part origin and circle center point. Okay, finish the sketch. Now we will activate the Revolve boss base command and select the vertical construction line for the axis of the revolution. And click OK. Now see. Now we will change the material of the part as polished bronze. Okay. Go to the lights folder and increase the ambient light from here. Now my model is looking very nice. And save the file with the name O-ring. Okay, that's it. Close the part file. Now we will create a new inch part file and choose the front plane, sketch. Now we draw a vertical and horizontal construction line over the part origin. Now we will create two lines on here. Select this endpoint of the line and center construction line. Fix the diameter dimension 0.13 inches. Now we will create another diameter dimension on here. It will keep 0.41 inches. Fix this vertical line dimension 0.07 inches. Okay, alright. Now we will create another line from this point. Okay, this dimension will keep 0.025 inches. Now we will draw some more lines, something like this. Okay, select this line and center line and fix the diameter dimension 0.375 inches. Now select this endpoint of the line and center line and fix the dimension 0.356 inches. Okay, that's it. Now we will apply some more dimensions on here like this to fully constrain the sketch. Okay, now see, finish the sketch. Choose isometric view. Now we will activate the Revolve boss base command from here. Okay, and select this vertical construction line. Now see, click OK. Now we will change the material of the model as polished steel. Okay, that's it. My part is looking perfect. Save the file with the name shock cartridge cover. Okay, alright. Now we will apply the fillet over this circular edge. Now we will apply another fillets on these edges of the part like this. Okay, close the par file. Now we will create another new inch par file. Now we will activate the extrude boss base command from here. Okay, select front plane to start the new sketch. Draw a circle from the center point. Its diameter will keep 0.25 inches. Now draw another circle on here. Its diameter will keep 0.135 inches. Okay, finish the sketch. Enter the depth value 0.165 inches and click OK. Now we will change the color of the model. I have already maintained a custom color on here. Okay, it looks great. Activate the fillet tool on here. And apply the fillets over the part edges like this. Save the part with the name shock cartridge spacer. Okay, click save. and close the par file. Now we will create another new inch par file on here. Okay. First of all, we will activate the Revolve boss base command on here. Choose front plane to start the new sketch. Okay, now we will create a vertical construction line over the part origin. And draw an center point arc from the center point. Okay. Now draw a circle over the center point. Fix the radius of this arc. It will keep 0.125 inches. Now we will apply the diameter of this circle. It will keep 0.125 inches. Now we will draw a vertical line over the end point of the arc. Okay, finish the sketch. Now we will select this sketch region and center circle and click OK. Okay, now we will open the visibility of sketch 1 on here. And activate the Extruded Cut command. Now we will select this circle. End condition will keep through all both. And click OK. Now see, my hole is created over this part and hide the visibility of sketch 1. Okay, now we will change the color of the part. And save the file with the name. .25 ball end. Okay, that's it. Close the file. Now we will create a new inch bar file. Okay, alright. And activate the extruded boss base command from here. Choose front plane to start the new sketch. Now we draw two circles from the part origin. The outer circle diameter will keep 0.25 inches and the inner circle diameter will keep 0.09375 inches. Okay, finish the sketch. Now we will choose the midplane option, okay, and enter the depth value 0.015 inches. Click OK and save the part with the name eClip. Now we will start the new sketch over the front face of this part. Now we will take the project of the entire face, okay. We will draw a sketch something like this. Create a vertical construction line over the part origin. Select these three lines and fix the symmetric relation on these lines. Bottom line dimension will keep 0.05 inches. And the top line dimension will keep 0.1 inches. Now we will apply the tangent relation between this line and the outer circular edge. And fix the angular dimension 25 degrees between these two lines. Okay, finish the sketch. Activate the Extrude Cut command and cut this sketch profile through all the base feature. Okay, let's start the new sketch over the front face. Take the project of this face, okay. Activate the offset entities command and fix the offset distance value 0.03 inches. Deactivate the select chain option, okay, and take the offset of the outer curve inside. Now drag the curve from this point. Now drag the curve from the end point. Okay, create an aligned line between this point and center circle. Now create a vertical construction line over the part origin. Now we will create a mirror of this aligned line on the opposite side. Okay. Now trim the extra arc on here. Apply the angular dimension 50 degrees between this aligned line and whole edge. Apply one more dimension 0.083 inches between these two endpoints. In the same manner, we will apply another aligned line like this over the opposite side and mirror it. Okay. Apply angular dimension 50 degrees between these two lines. And fix another dimension 0.0396 inches between these two lines. Okay, alright, finish the sketch. Now we will activate the Extrude Cut command and select these two sketch profiles like this. And the condition will keep through all. Click OK. Now see, it looks great. Now we will apply the fillets over the corner edges of the E-clip like this. Now see, my E-clip is looking perfect. And change the material of the part as polished steel. My E-clip part has been completed on here, so we will close the part file. Let's start the new part file. Okay, I'll choose the Extrude Boss Base command and select the front plane to sketch. Create a circle from the center point. The diameter will keep 0.125 inches. Okay, finish the sketch. Depth value 1.25 inches. Choose the mid-plane option. Okay. Save the file with the name Shock Shaft. Start the sketch on the front face. Create a circle on here. Diameter will keep 0.112 inches. Okay, finish the sketch. Fix the depth value 0.225 inches. Okay, that's it. Now we will create a plane at an offset distance value 0.032 inches inside from the back face. and start the sketch on this plane. Now take the project of the two circular edges like this. Okay, finish the sketch. Activate the Cut Extrude command and select the sketch region. Fix the cut depth value 0.015 inches. And click OK. Now see, my slot is cut on this circular face. In the same manner, we will create another slot in the following way. Now we will apply the chamfer like this. Okay. Activate the cosmetic thread command and apply the thread on the front side circular face. Size will keep 4-40 and click OK. Now my shock shaft has been completed on here, so we will close the par file. Let's start the new par file on here. Click OK. I will choose the Extrude Boss Base command and select the front plane to sketch. Create a circle from the center point. Diameter will keep 0.4 inches. Finish the sketch. Now choose midplane option. Depth value will keep 0.115 inches. Okay. Save the file with the name ball end. Let's start the new sketch over the front plane. Now we will activate the section view by selecting this plane. Okay. Now draw a horizontal construction line on the center part origin. Now we will draw the three lines like this by connecting the outer edge of the base feature and draw an arc on here to close the sketch. Now select the center point of the arc and this line. Okay, choose make coincident. And fix the 0.225 inches dimension between this point and the end point of the line. Now we will apply the diameter dimension between this line and center construction line. It will also keep 0.225 inches. Okay, finish the sketch. Now we will revolve this sketch profile on here. And start the sketch over the front plane. Now take the project of the outer surface of these two features. Draw a horizontal construction line on the center part origin. Now I will create a vertical line, okay, and create another line I will connect from here to here. Okay, now I will create another one. Okay, that's it. I will select this line and this line. Okay, now I will choose make symmetric relation. Okay, that's it. Now this line dimension will keep 0.1375 inches. And now this dimension will keep 0.3961 inches. Okay, now I need to apply one more dimension between these 2 points to fully define the sketch. Okay, it will keep 3154 inches. Alright, now choose exit. I will select the extruded boss base command. Now I will select this one and end condition will keep midplane. Okay, see. Now I will apply the fillets over all 4 corner edges. Okay, now my part is looking perfect. Now I will activate the split line tool from the curves tab. Okay. In the split bodies selection section, we will select the front plane. Okay. Next, in the faces section, we will select this outer curve face. Okay. Alright, now see the result. My face is split on here. Now we will activate the draft tool. Okay. In the neutral plane section, at first we will select the front plane. Okay. Now rotate the model in the top view. Okay. In the faces to draft section, we will select the left face of the part. Okay. Fix the draft angle value 5 degrees and click OK. Okay, now see the result. My left portion of the part has been bent by using this tool. Okay, that's it. In the same manner, we will bend the right portion of the part by using this tool. Okay, alright. And now we will activate the hole wizard command from here. In the hole type section, we will choose straight option. Okay. Standard will keep ANSI inch of the hole. Now we will select the hash 4-40 size under the hole specification area. Hole depth will keep 0.225 inches. Okay. Now go to the positions tab and select this face for creating the hole. Now hover the cursor over the center point to locate the center point of the hole and click OK. Okay, now see the result. My tapped hole is created over this face, and apply the fillets on this circular edge. The fillet radius will keep 0.015 inches. Okay, that's it. It looks great. Save the part file. Now we will apply some more fillets over this part like this. Now we will apply the chamfer over the whole edge. The chamfer distance value 0.015 inches. Okay, alright. Now choose front plane, sketch, and activate the section view by selecting this plane. Okay, alright, choose front view. Now I will choose the line tool and create a line on here like this. Now select this line and center part origin and choose make midpoint. Okay, that's it. Now we will create a 3-point arc between the end points of the line like this, and its radius will keep 0.125 inches, and apply the coincident constraint between these 2 points. Okay, finish the sketch. Now rotate the model in isometric view. Activate the Revolve cut command. Okay, select the sketch. And click OK. Now see. Deactivate the section view. Now see, my another hole is created over this part. Now select this edge and apply the chamfer on this edge. Choose distance option and fix the distance value 0.005 inches. Create another chamfer over the opposite side edge of the hole. Now we will change the material of the model as sandblasted lead. Okay, that's it. Now we will increase the ambient light from here. Okay, and we will the directional light on here. Okay, now we will set the direction of this light. Okay, now see, my part is looking very bright. Okay, save the part file. Now my part has been completed on here, so we will close the part file. Finally, all the part files of shock absorber model are finished here. Okay, that's it. First of all, we will create a new inch assembly file from here in SolidWorks. Okay, alright. Now see, the begin assembly command is already being activated here. Browse the file from here and place the part file ball end. Okay. Change the light of this part from here. Okay, it looks good. Create another part in this assembly. Okay. Now we will activate the mate command and select the origin point of this part, and next select the origin point of the assembly and apply coincident constraint. Okay. Now see the result. Save the assembly with the name ball end. Okay, that's it. Create another new assembly and place the part shock shaft. Okay, snap the origin points of this part and assembly origin. Now my model is fully defined, and save the assembly with the name shock strut. Okay, that's it. Now we will change the color of this part, change the material of this part, choose sandblasted steel. Okay, it looks good. Hide the visibility of the assembly origin. Now we will place the piston part in this assembly. Now see the result. Place another part, E-clip. Okay. To use the push pin option in the insert component dialog box, to insert multiple copies of the same part. This option is very beneficial for multiple copies of the part to place in the assembly environment. Place another E-clip. Okay. Select the whole of piston and shock shaft and apply concentric constraint. Okay. Select the face of E-clip and back face of piston and apply coincident constraint. Okay, that's it. Select this face and select the E-clip face and apply coincident constraint. Cylindrical face and select this cylindrical face and apply concentric constraint. Alright. Drag the part from here, select this face of the part and this face of the pin and apply coincident constraint. Now we will place the part ball end. Okay, now see the result. Select this face of the assembly and this face of the pin and apply coincident constraint. Okay, select the outer cylindrical face of the ball end assembly and cylindrical face of this pin and apply concentric constraint. Now we will place the part spring cup in this assembly. Now see the result. Select the face of spring cup and this face of the ball end and apply coincident constraint. Select the whole of spring cup and the cylindrical face of the pin and apply concentric constraint. Save the assembly. Now we will create a new assembly. Okay, and place the part shock cartridge. Okay, this part is fully defined in this assembly. Save the assembly with the name shock cartridge. Okay, that's it. Now we will activate the insert component command and place the part O-ring in this assembly. Okay, select this axis of the shock cartridge and axis of the O-ring and apply coincident mate. Now open the visibility of plane 1 and plane 2 of the O-ring. Okay. Select the plane 2 and the face of shock cartridge and apply coincident mate. Okay, that's it. Save the assembly. Okay, now we have placed the part shock cartridge spacer in this assembly. Now we will change the color of this part. Okay, return back to the assembly. Select the cylindrical face of the shock cartridge spacer and the cylindrical face of shock cartridge and apply concentric mate. Okay. Now we will activate the section view by selecting the right plane. Okay, select this face of shock cartridge spacer and select the plane of shock cartridge and apply coincident mate. Okay, now see, that's it. Now we will place the part shock cartridge cover in this assembly. Okay, alright. Now deactivate the section view. Now rotate the model by using the move with thread command. Okay, now select the face of the hole. Next, select this face of the hole and apply concentric mate. Drag the model like this. Now we will place another O-ring in this assembly. Activate the section view command. Okay, select the plane 2 of O-ring and this face of shock cartridge and apply coincident mate. Now select the axis of O-ring and axis of shock cartridge spacer and apply coincident mate. Select this face and the internal face of the spacer and apply coincident mate. Okay, alright. Deactivate the section view from here. And save the assembly. Now we will create another assembly and place the part shock body 1.3 length. Okay. Now we will place the shock cartridge part in this assembly. Select the circular face and this circular face and apply concentric mate. Okay, drag the part, select this face and this face and apply coincident mate. Now see, my assembly is fully defined. Select this face and apply angular constraint, angular mate. Set the angle 0 degrees and click OK. Save the assembly with the name shock body. Okay, that's it. Now we will create another assembly. Open the visibility of the assembly origin. Now we will place the shock spring adjustment nut in this assembly. Okay. Activate the insert component command and place the part suspension spring in this assembly. Now see. Select this face of the spring and rotate the model by using move with thread command. Select this face of the hole and select the axis 1 of the spring and apply concentric mate. Okay, my spring is placed over the center point of the shock spring adjustment nut. save the assembly with the name shock absorber. Okay, alright. Now place the shock body assembly in this assembly. Okay, rotate the shock body assembly in this position. Select this cylindrical face and this cylindrical face and apply concentric mate. Okay, now see. Select this face and apply the distance mate. Set the distance value 0.4003 inches. Okay, that's it. Select this face of the shock body and this face of the shock spring adjustment nut and apply angle mate. Okay, the angle mate will keep 0 degree. Now we have insert the shock strut assembly in this assembly. Okay, select the shock strut assembly, activate the move with drag command and rotate this assembly in this position. Select the cylindrical face of the rod and select this face of the hole and apply concentric mate. Okay, alright. Drag the ball end assembly, select the face of the spring and select this face. Okay, and apply coincident mate. Select this face and apply the angle constraint. Set the angle value 0 degree, click OK. Now see the result. Now we will activate the section view by selecting the right plane. Okay. Now drag the assembly, select the face of E-clip and select the face of shock cartridge cover and apply coincident mate. Okay, now see the result. Okay, drag the ball end assembly. Now my shock absorber assembly is completed. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. Okay friends, goodbye.